Be going over Python 2.7, the introduction or basics of Python 2.7. I'll be talking about how to use this software basically in terms of using some of the basic concepts within it, such as variables, primitives, other kinds of ways in which we create simple lines of programming to create some basic functionality. We're going to be using Python 2.7 in this course. We'll be using the Eclipse development environment for most of the course. However, I'll be using the Python IDLE today to demonstrate some of these basics that we'll go over. The reason why we choose Python is because it's relatively simple in syntax. That is, it's relatively clean looking. The way to define the variables is very simple. To do things like loops, other kinds of functionality are relatively simple in comparison to other languages. And it's also very common. It's a language now that's used by a number of industry people, academics, and certainly in GIS and other areas of research and also just general applicability or applications. Python is very common. So it's a good useful language to know. The point of this course is not going to be to make you Python programmers, but the reason why we're using Python is that you can begin to understand some basic concepts in computing that allow you to solve larger kinds of problems. So think of Python as a default tool that helps you to know other tools. So you can build off of Python to know things like Java, C#, or other kinds of languages you might be interested in. So the tools of Python, as I mentioned, include the Python IDLE. We'll be using 2.7, which is here, and I've activated it already on my desktop, so you can see it over here. We'll be using it in a moment. And we will also be using the Eclipse development environment. I'll talk more about that in class next week, but Eclipse makes things a little bit easier in terms of actually developing programs and software. It's nice functionality in debugging the code, looking at what methods are available to you, accessing libraries, and other kinds of things that are useful for developing more sophisticated software. So Python allows you to define any type of variable by being explicit about, without necessarily being explicit about that variable. So Python essentially allows you to create a simple variable and then give it some kind of value. So variables include numbers, strings, which are basically letters, or think of them as kind of words or sentences, any kind of text basically. Lists are essentially like arrays. They kind of contain information, multiple sets of information, whether it's numeric or again, or even numeric or potentially written kinds of information. Tuples are similar to lists. They're basically read-only lists that contain information. They look a little bit different than lists in Python, essentially having parentheses rather than brackets, but we'll talk about that in a second. And then dictionaries are another common kind of variable. Dictionaries think of them as hash maps. They're basically a kind of container where you have a reference information, that is a name of a kind of variable, and then a value to that variable. So the reference identifies what the item might be. So a name of a person might be called name, and the person's name might have to be the value. So John, for instance. So it's a key, that is the reference, and the value that make dictionaries different from other kinds of variables. So we'll be defining all these throughout the lesson today, so you'll see examples of what I mean. So numbers, as I mentioned, are defined simply in Python. All you have to do is simply indicate a value. So let's start off with a basic example. So for instance, if I want to do var1 equals 1, I simply type var1 equals 1, and var1, lo and behold, has that value. Oh, sorry, I typed the wrong thing. So var1 and then var1 returns 1. Same thing with var2 equals, let's say 10 or whatever I want to give it. And then var2 returns the value 10. I can also delete these values. So delete is a keyword in Python. So del essentially removes a specific variable from the program. So if I have defined var1 previously, I can now type del var1, which will then remove it from the software. So if I type var1, it should return an error because it's been removed. So you can see var1 has been removed from the program. Okay, so you can do this again with all the variables that you define. You don't have to delete them. It's not necessary, but it's something, an option that you can do that within the program. So we'll talk more about that as we go along. So sometimes you will need to specify the type of variable. For example, a float versus an integer. So some numbers, you don't necessarily want just integers, 1, 2, 3, 4, 5. Those are integers. And sometimes you want, say, 1.6 or 1.7 or some kind of decimal place in your values. And so basically that's oftentimes a kind of a float. There are um, other kinds of ways to define these. Sorry, don't want to open that. But floats are a typical way in which we define decimal places in Python. There's more sophisticated ways actually to utilize things like doubles, for instance, in other languages, but floats are sufficient, I think, for our purposes here. So to define a specific type of variable, let's say an integer, let's say first we define a variable x equals 2. That is, x is just given a 2 value. But now I want to specify that x has to be an integer. That is, 2 has to be an integer in terms of the program. So I simply go int x, and then I look at the value, and it tells me that int x is now 2. So it's integer 2. So it's basically the same as what I initially gave it. But what if I wanted to actually make it a kind of decimal place value? So I give it something like this, or I give it x and float. In this time, I define it through float with the input x. That is the variable I've given it initially. And now I return 2.0. So what happened there was basically I gave it the x value, that was 2. I defined it now as a float, and so it makes it into a 2.0 value. That is a type of float variable which has decimal places, so think of it that way. It's kind of allocating memory within the Python environment, so that's why it's defining it differently than an integer. It takes more memory, however, it gives you more capability, of course, to utilize things more than just integers and decimal place values. Now, Python, of course, has also things like strings. Strings, are, as I mentioned, are essentially letters or words or whatever it might be in terms of written content. It could also be numbers that are written as letters, essentially, or as a kind of printed information. So the simple or basic kind of example is hello world. Okay, so hello world is the standard that we use in a lot of computing programming for our introductory kind of purposes. So hello world, so now I'm telling it that basically str, the variable str, equals hello world. And you see the quotations given that define it as a string. So the quotes given at the beginning, at the end, say this is the following information. All that information within those two quotes are what defines the str value, the string value. So you can see now, if I want to see what str equals, I simply type it and press return, and I get hello world. So you can see it's been defined as hello world, and that's the value essentially of str. Okay. So now lists are another type of variable that we have in Python. They're quite useful, and you'll find them, I think, throughout this course very useful because they contain multiple types of information. They can contain numeric or alphabetical or any kind of written information, as well as floats and integers. So they can contain a diverse set of different types of variables. So let's say I have a list and I want to define it as something with written content, A, B, C, D. Okay, so I give it the quotes again. So double quotes or single quote doesn't really matter in Python. So A, B, C, D is a kind of string. And then I want to give it a numeric value, 786. And then I want to give it a kind of float value, 2.23. And then perhaps another string as well. So I can do simply like that. And then now I've defined a list equals the following sort of set of values that I've given it essentially 4 values, A, B, C, D, 786, 2.23, and John. Okay, so now if I say list, I get the following, and I get the values that I've given it. So it has essentially 4 values within the variable list. So how do I access specific values in that list? Well, what you can do is basically reference the reference number. So like many programming languages, Python uses 0 as a starting point reference. So 0 refers to the first value in the lists, 1 refers to the second value in the list, and so on and so forth, depending on how many values you have. So what you can do is basically, if you want the first value, you go simply as like this, list 0, and that returns, or should return, the first value. Okay? So that's how you basically access values within lists. tuples, as I said, are basically read-only lists. I don't use them, to be honest, that much. You can, tuples are basically defined using the parentheses rather than the brackets. So you can, similar to what we just did before, A, B, C, D. You can use 786 again, or John, or whatever it might be. And then, so we have here a tuple, a defined tuple using the parentheses. You have, again, sort of written or alphabetical information or whatever it might be, defined as strings. And you have also the numeric value, 786, another string value, John. So we have three values in the tuple. So if I say tuple, I get these three values. So I've defined a variable called tuple. And now I can also access the tuple values, similar to as you would with lists, just by referring to the numeric place or information. So tuple 1 should return 786 because it's the second value. So remember, 1 is actually the second place. So because we start at 0 in terms of the location of information within things like lists or tuples. So I get 786 back. Dictionaries, I mentioned, are similar to hash tables. They have keys and values. So as I mentioned, a kind of referencing, which is called a key, and then the value, the reference value. So to create a dictionary, I would do something like, say, tiny dictionary, whatever you want to call it. And then I use these curly brackets, and then I give it the key, which in this case is name. So name will be a key. And to give it the value, I do this colon, and then I give it on the right side of the colon the actual value. So what I'm saying is the key John has a value, or the key name, excuse me, has the value John. And so keys are oftentimes strings because it's essentially the easiest way, or an easy way, to reference a kind of information using just a string. But the value can be a string or a numeric kind of value. So code, for instance, could be the name of the key, and then we give it a numeric value in this case. So say you're writing a website or any kind of database, this is going to be quite important because you can reference a lot of information using things like dictionaries. So we'll probably visit this issue or this kind of variable much later on, But this is just to give you a quick example. I can also see what kind of keys are in it if I forget. So let's say I have all these keys and I forget what values they are. So keys is a method built in within dictionaries, defined in Python. So if I type keys, I should get the following keys. So code and name. So those are the two keys I've given the variable tiny dictionary or tiny dict. Okay. So now I'm going to get, let's say I want to return the actual a value specific from that, so tiny dict, and then I put name. So instead of referencing a number like we did with lists, this time I'm referencing the actual key, the specific reference information. So name was the reference information. So now it should return John because I'm telling it to return the value in regards to reference name. So that means John should be, oops, I did it wrong. Oh, because I wrote the name variable wrong. So if we do it again, yeah, so you get John back. So tiny dict, basically I want the name and I get John, okay? So operators, what are operators? Think of operators as a bit of code that modifies a variable, the variable being the operand, something that's affected by the operator. So in a simple example, if I did 4 plus 5, essentially the plus sign is the operator, and you could see it's going to make something called basically, or make 9 as you add the two together. So plus is an operator. So operators are what give functionality and capability to your code. So example kinds of operators you find in Python include, of course, plus and minus, multiplication, division. There's what's called the modulus. So plus, minus, division, and multiplication are pretty simple. They're standard, as you might find in many languages. So 4 plus 5, as we did, or 4 times 5, excuse me. We can do, of course, 4 divided by 5, and we get 0. In this case, because we're only returning an integer, we should define it as a float. perhaps. So in this case, so let's say 4 divided by 2, we get 2, of course. So modulus, will tell us how much is to be returned. So let's say I want to do 5 mod 4. So what do you think the result will be? It should be 1, right? Because if you divided 5 with 4, you should get a remainder of 1. So the remainder of 1 is what returns. So essentially it returns the remainder value. Now, raising something to the power, you simply give it the 2 stars, the 2 kind of multiplication signs. So 4 to the 5th power should be written like this, essentially. And then you get the result of that. Okay? Okay, so now in terms of division, I made a mistake previously. So if you want to get a remainder, what you do is write 2 floats. So remember, floats are essentially decimal place kind of values. So 4.0 divided by 5.0 returns what 4 divided by 5 is, which is 0.8. So you can see that's how you write that. So if you write it as 4 divided by 5, what you get is just the integer result. In that case, 0, because 0 is an integer. The integer that's the lowest integer when you divide 4 by 5. Okay. Now, if I want to see something is equal something, what Python does is it gives you an operator of the 2 plus or 2 equal signs, excuse me. That's usually used to check if something is true or not. It's a kind of system to see, a kind of logical system basically used within Python, and most computing languages use the same thing actually, as a way to have a kind of check to see if 2 values are equal. So let's say I define A as equal 2 and B equals 2. Now if I want to see A equals 2 as well, or if A equals B, I simply do A if, or A equals B. What I'm writing is a logical statement, so if is a logical statement, and I'm saying A equals B, then I'm going to say print hello. So I'll tell it to print basically hello if that's the logic is true, and you can see it printed. So what happened there is I defined 2 variables, A and B. I made them both 2, and then did a simple quick check saying if A equals B. So to say if 2 values are equal to each other, use the 2 equal signs, not the 1 equal sign. The 1 equal sign is essentially an operator. It tells some variable it'll be equal to that. The 2 equal signs is a kind of conditional check. It's a way in which you can see if 2 values are actually equal to each other. So here I have an if statement that's checking if 2 values are equal to each other, and if they are, what it's going to do is print hello. Notice, we'll talk more about if statements in a moment, that we use the colon sign after the if statement, and indentation is very important in Python. You have to indent where you put your specific commands after particularly things like for loops and other loops, while loops, as well as conditional statements. We'll be showing more examples of that later on, but for now, this is how you do a way to check the equality of 2 variables. Now, what if I want to do what if I want to see if 2 values are not equal to each other? Okay, well, let's say we define A as 3 now, and then B equals 5. So if I did if A does not equal B, then print see you later. Okay, so basically now instead of saying if A equals B, I'm saying if A does not equal B. So the not is given by this exclamation point and then equal sign. So this is the sort of sign that's highlighted here for not equals. So if A and B do not equal each other, and they should not equal each other because I've defined them as 3 and 5 respectively, that means we should see something saying see you later. Okay, so I press return and it says see you later, which means that the conditional is true, that is A does not equal B. Now there's other ways to write it. You can use these sort of greater than or equal to signs as well. So you can do this as simple ways to do this check. And then you can see the same result. So it's just another alternative sign for doing not equals. And then you have, of course, the greater than or equal to signs, or less than and less than equal to signs. So if A is greater than B, print hi. and you see that A did not print anything, or the result of that did not print anything because A in this case is less than B, right? So A is only 3 and B is 5, so it didn't print high. However, if I did this, it should print, right? So if B is greater than A, then we should see sort of results, right? And we get high. So that's kind of how you do greater than equal to. And then you can add the equal, or excuse me, greater than or less than signs. You can also then, of course, add the greater than or equal to sign as well. So something like that. And again, it won't print because this time it doesn't equal or is not greater than. Whereas if we wanted to do this sort of okay, right, okay. So let's see.